Before Thanksgiving break, we reviewed the properties of exponents, and so this lesson is expanding on what we learned about the properties of exponents in Algebra 1 and Algebra 2, and learning how to manipulate exponential functions using those properties. So here is a little recap. We learned about the product property, so that's when you multiplied two numbers with the same base b, then you would add the exponents, m plus n. So for example, if we had x to the fifth times x to the third, add your exponents, you get x to the eighth. And the same is true when our base is a number instead of a variable. Power property says if you have a base to a certain power and then you raise that to a power, then you're going to multiply those two exponents together. For example, x to the fifth to the third power is going to be x to the 15th. And lastly, the negative exponent property says that if you raise a base to a negative exponent, in order to turn that exponent positive, we are going to use the reciprocal. So we are writing 1 over b to the n. Here is the general form of an exponential function. Using what we learned about transformations in the past, describe what each transformation of each function would be. We know that when there is a change in x using adding or subtraction, that is a translation, a horizontal translation. So in case number 1, we can say that y equals 2 to the x, the original function, is horizontally translated to the right 3 units. For our next function, we say the parent function, notice it's just the base and the exponent, 1/5 to the x is vertically dilated by 4 units. That means the last one, y equals 3 to the x, is horizontally dilated by 1/2. And again, that's because anytime we are multiplying a number to x, when it's a horizontal dilation, we are using the reciprocal. So because that's a 2, we say it's horizontally dilated by its reciprocal, 1/2. Let's get some more practice. Determine the horizontal transformations of each of the following exponential functions. Here are your answers. Now, hopefully you guys are using the term horizontal translation instead of shifted. I'm trying to level up our language here in AP Pre-Calculus. This first function from our last example demonstrates the product property, the result of a product property. So how can we work backwards to reverse the product property? Working backwards, that would be 4 to the x times 4 to the second power, right? I'm just reversing this. What is 4 to the second power? 4 to the second power is just 16. So another way of viewing this exponential function would be to write it like this, in that original form that we learned of a times b to the x. And so we saw over here that this looks like we take 4 to the x and we have a horizontal translation to the left too. But if we're viewing it from this perspective, what transformation is applied to 4 to the x power? So on this side, we have a horizontal translation by -2. That's another way of saying left 2. On the other side, we have a vertical dilation by 16. So applying each of these transformations would result in the same graph. So important idea. Every horizontal translation of an exponential function, f of x equals b to the power of x plus h, is equivalent to a vertical dilation of the exponential function y equals a times b to the x, where a is b to the h, or in this case, 4 to the second power. Example 3 gives us an exponential function that looks like it was created using the power property. So to rewrite this one, I am going to put 9 to the second power in parentheses and then raise that to the power of x. And that's how we originally got 9 to the power of 2 times x. And what is 9 to the second power? That's just 81. So this is equivalent to 81 to the power of x, which is d. This rule here is review from Algebra 2. It's the rational exponents rule. And that says if we have x to the power of 1 over n, that can be rewritten as the nth root of x to the first power, which is invisible. If it's not having a numerator of 1, then we can write that as x to the power of m over n, which will be written as the nth root of x to the power of m on the outside, or you can keep that m inside the parentheses. Both of those are the same. Example 4 says, which of the following functions is an equivalent form of the function 9 times 4 to the x? I'm noticing that all of my answer options have 16 as a base. So the question is, how can I rewrite that 4? How can I manipulate that 4 to write it with a base of 16? So let's manipulate our answer options then if we're having trouble manipulating the original. So I'm going to rewrite this, first of all, in a way that makes more sense to me. Y equals 3 times 16, and x over 2 is the same thing as 1/2 x. And now, hopefully, we're making a connection with why we just talked about that rule for converting. So I can convert 16 to the power of 1/2 into radical form. If I convert that into radical form, the denominator goes on the outside of the radical. That 16 stays inside, and I raise that to the first power, which we know is typically invisible. So really, and also that 2 is invisible. So really, that is just the square root of 16. And what is the square root of 16? It is 4. Let me fill in the rest of this equation. So here is what I'm left with. 3 times 4 to the power of x is equivalent to this first answer option, A. And I am trying to make it match this one. So I have one piece that's working out, right? That 4 to the x is the same, but I need it to have a 9 in front. So it's not going to be this option here. It is going to be C, because really the only difference between A and C was that number in front. So if I change this to a 9 all the way down, then that's going to match that original equation that was given. So to recap, another way to write 4 is 16 to the 1/2, because it can convert that in radical form, and that is just the square root of 16.